So the core is very dense, the density is greater than 11. It's very hot, 3000 to 5000 degrees centigrade. We have seen outer core and inner core 2800, 4800, and it has abundance of nickel and iron. The outer core, it is molten because of silicon impurities along with the nickel and iron. The inner core is relatively pure, therefore it is solid. So this setup results in something called geomagnetism. We'll see it later. The entire structure can be seen here. So this is a continental crust, this is the oceanic crust, this is the upper mantle, middle mantle, inner mantle, outer core, inner core. It's 350 multiplied by 2, 700 into 4, 2800, and we can remember 4800 and 6400. Now we are going to the mechanical differentiation. Based on type of composition and how they behave, some layers behave as a single unit. This is the mechanical differentiation. So these layers are lithosphere, asthenosphere, mesosphere, and barysphere. Lithosphere consists of crust and upper part of upper mantle. Asthenosphere consists of rest of the upper mantle. Mesosphere consists of remaining mantle, and barysphere consists of the core. Therefore, the depths are 100 kilometers, 350, 2800, and 6400. So the lithosphere is brittle, it's cold, and it's not continuous. Therefore, it is broken into something called plates. So there are three types of plates: oceanic, continental, and both. They are floating over the semi-molten asthenosphere because of the olivine. Now there are some other models of Earth's interior which are given by Edwards' CLCMA knife model. The depths are 300,000 to 2000, 6400, and the specific densities are 2 to 3, 3 to 4.7, greater than 5. And this contains continental crust, this contains ocean and mantle, this contains the core. The model given by Daly and Arthur Holmes, it's about silicates, outer, intermediate, and inner silicates. This consists of mixture of the igneous rocks we talked about, grandiorite, amphibolite, ecolgite, and peridotite. So the depths are given here. And the Van der Graaf model, it is very close to our contemporary understanding. Outer silicates, inner silicates, mixed silicates, inner metallic layer. Depths are 60 kilometers, 60 to 1100, 1100 to 2800, greater than 2100. The first thing consists of only continental crust. It consists of upper and middle mantle. It consists of middle and inner mantle. This consists of core. Now we are going to the conditions of Earth's interior. Based on the density and rigidity, the crust and outer layers are solid and brittle. Asthenosphere is semi-molten. Mantle layers are dense and relatively softer. Outer core is fluid, as we talked about. Inner core is solid. The molten magma circulates in the mantle. This is called as convection currents. This is given by the Arthur Holmes. So this is something how the convection currents happen. And coming to the temperature, within the lithosphere, up to 100 kilometers, the temperature rises at 2 to 3 degrees centigrade per 100 meter. Beyond that, there is no uniform pattern. At tectonic locations, very high temperature of 1000 to 1500. Asthenosphere has 1000 to 1500, deep mantle has 2000, core mantle boundary has 3000, and core has 4000 to 5000. So where does this heat come from? Two sources: radioactivity and residual gravitational heat. This is from the nebular hypothesis, from the solidification of ancient nebula. Radioactivity through fission reactions. So there are certain discontinuities. These are the layers that separate the distinct zones like lithosphere, asthenosphere, core and mantle, etc. So the moho separates the continental, the crust and the mantle. So there are two types of depth. It is shallow at oceans and deep at continental. And repetitive birch, it is debated whether it is there or not. So it is between middle mantle and the inner mantle. Gutenberg is definitely there. It separates the mantle and outer core. And Lehman separates the outer and inner cores. The Conrad discontinuity separates the continental crust, the more felsic part and less felsic part. It is not present in the ocean because ocean is too thin for any such separation. So the evidences of Earth's interior, the Earth is very deep, 6,400 kilometers. So we do not have direct physical evidences. So most of our inferences are from the indirect extrapolations, and very few are from direct observations. Some of the direct evidences are volcanoes, mines, meteorites, deep trenches. So remember this South Sandwich Trench at South Atlantic, where mantle is exposed. The indirect studies are two types: density studies and seismic wave studies. This is not important. This is important. Seismic wave evidences, whenever there is an earthquake, there is an energy release. There are two types of energies released: radiations and mechanical waves. These are gamma waves, IR, etc. So they do not require any medium to transmit. So these are not important for our studies. And the mechanical waves, these are a set of vibrations and they need a medium to transmit. So based on the properties of these waves, we can understand how the composition of medium is, that is density and rigidity.